what we're going to do is we're going to solve what's called systems of equations. We're going to solve them graphically. So here's our system. System is two equations, and we're going to graph them and see where the lines cross. So the first one, well, to do that, we want to graph it in slope-intercept form. So our first one is y equals 2x plus 1 when we change it. So I go to 1 is my y-intercept. I go up 2 and to the right 1, and then I draw a line. Then the second equation, I'm going to go down to negative 8. 1, 2, 3, 4, 5, 6, 7, 8. But I'm going to go down 2 more, 2.5, and I go right. And then I'm going to draw that line. And then I'm going to look at where they cross. It looks like it's roughly 1, 2, 3, 1, 2. So it looks like a negative 3 and a negative 2. And so that's my approximate solution to this problem by graphing. Now let's look at the next time in this type of problem, and I'm going to do it a little differently. I'm going to use the xy intercept. So if I find the x-intercept means make y 0, and when if I divide, so now I'm going to find the x and y intercepts. So the x-intercept is y equals 0, so x would be negative 2/3, and my y-intercept will be when x is 0, and so that would be a negative 1. So now I can go to negative 1 on the y line, negative 2/3, which is somewhere right in here, and I can connect them. And that would be my xy intercepts for that one. So let's do the x-intercept for this problem. That means make y 0, and that would be a 7. And the y-intercept would be divide negative 28 by 5, which would be roughly negative 5 and 3/5 or 0.6. So now I can go to the x line, 1, 2, 3, 4, 5, 6, 7. And I go down on the y line, 1, 2, 3, 4, 5, so almost 6. And I connect them. And I'm looking for where they cross. They cross right here, so it looks like 1, 2, 3. 1, 2, 3. So it looks like it's 3, negative 3 is my approximate answer. And that's all we're trying to do is get an approximate answer through our graphs. So we're going to look at classifying systems of equations. And classifying systems are looking at two lines on a graph. So here are the three types that we have. When we have two lines that cross each other in a spot, those are consistent because they have an answer. And because they go in opposite directions, they're independent of each other. Then the second type we have right here is a consistent because we have an answer because the lines cross, but they cross each other on the same line. So they are dependent on each other because they're going in the same direction. And then the last type of system we have is when they don't have an answer. That means they're parallel lines. So that's inconsistent, and obviously they don't depend or they're not independent from each other. So let's look at our first example here. We want to look at the graphs of those, which we have right here. And the question is, are these lines consistent, inconsistent, dependent, or independent? So first off, they have an answer. They cross right in this spot. Since they cross, they're consistent. And also because they only cross in one spot, they're also independent of each other. So these are consistent and independent because they go in opposite directions. Let's look at our next line. These two graphs right here create one line, and so one line means they do cross each other, so they are consistent. And because they are going the same direction, they're dependent on each other. Basically, they are the same exact line.